Myself, Professor Neeta Nemade, we will learn about analog and digital electronics, in that combinational logic circuits. As the name to these circuits, combinational logic circuits, here we have the different combinations that of different logic gates. Under this, we will learn about the design for this combinational logic circuit. In that, first we will see the designing steps. Four designing steps are there. First one, as assign variables to the inputs and outputs. In the second step, we have to prepare or write down logic table for that circuit. Using the variables assigned for inputs as well as outputs. The third step is to find out Boolean equations for all these outputs, output variables, using Carnap map, also called as the K-map. And the fourth step is that draw logic diagram using these equations. So first of all, we will go for the design of the adder, as half adder as well as the full adder. In the adder circuits, we will use addition rules. Those will be given as 0 plus 0 as 0, 0 plus 1 as 1, 1 plus 0 as 1, and 1 plus 1 as 0 with carry as a 1. So here we have the carry and this is our sum output. This additions rule we have to use for the adder circuit. Using these addition rules, we will prepare the table for these adder circuits. In that, first of all, we will see half adder. We will go with its block schematic. So half adder is used to add 2 bits, call them as A and B. And the outputs are here as sum output and the carry output. So the first step we will follow, that assign variables to the inputs and the outputs. So here we will assign the variables as inputs as A and B and the outputs as S0 and carry output as Cout. Using these variables, we will prepare the table. So second step we will follow, and here we will write the truth table for this half adder circuit. So inputs assigned as A and B, and outputs assigned as Cout and SG. As two inputs are there, we know that we have 2 to power 2, that is equals to 4 combinations are there, that of the inputs, and those are as 0, 0, 0, 1, 1, 0 and 1, 1. Here we will apply the addition rules. So 0 plus 0 as 0, 0, 0 plus 1 as sum output as 1 and carry output as 0, 1 plus 0 again Cout as 0 and sum output as 1, 1 plus 1 C output as 1 and carry sum output as 0. Using this truth table, now for the outputs, we will find out the Boolean equations using the Carnap map. As here we have two input variables, we will go with the two variable K-map. So here we will say that K-map for Cout. This is the two variable K-map. Inputs are as A and B. Cell numbers be given as now observe the C output variable. So here it is 1, 1. It is 1. So we will write here 1. Single 1 is there in this K map. So we will write it equation Cout is equals to here as A dot with B. Same way we will go for the S0 K map. So we will have here K map for S0, that is sum output. Again here we will go with the two variable K map, as we have two inputs as A and B. The cell numbers be written in this way. Now observe here this column for the sum output. Here we have 1 for 0, 1, that is 1, and 1, 0, that is 1. So here we have 1. So here we will write S0 will be equals to, for this one, no pair will be formed. So we will consider individual one. For this one, we will write it as A dot B complement, and or with, for this one, we have A complement dot with B, and this is nothing but A XOR with B. So here we have find out the equations for the both output variables Cout as A dot B and sum output as A XOR with B. Now using these equations, we have to draw the logic diagram for the half adder. So here logic diagram for half adder. Inputs are as A and B. So here this is A dot B as the carry output C out and A XOR with B as the sum output, that is H. This is the logic diagram for the half adder. Same way we will go for the full adder. First step is assign variables to inputs as well as outputs. Here we have two inputs as A, B, and the third input be given as the carry input, that is C. Then we have the outputs as sum outputs S0 and the carry output as C out. There is one disadvantage in the half adder, that we will be able to add only two single inputs. And here in the full adder, we will be able to add 3 bits, and because of that, any number of bits we get added with the help of the chain of this full adder. Here we have assigned in the first step the input variables as A, B, C in and the output variables as C out and H0. Now using these input variables as well as output variables, here we will prepare truth table for the full adder. Inputs we have assigned as A, B and C input. Outputs we have assigned as C out and S0. Then here we will write the decimal number equivalent for these inputs. Now as 3 input variables are there, we have 2 to power 3, that is equals to 8 combinations are there, and those combinations are from 0 to 7 will be given as 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. The decimal equivalents for these as 0, 1, 2, 3, 4, 5, 6 and 7. Now we will use here the addition rules as 0, 0. 0 plus 0 plus 1 as 0, 1. Again as 0, 1. 1, 0. 0, 1. Here we have 1, 0. Here again 1, 0. And for the last column row, that is 1, 1, 1, we will add here as 1 plus 1, 0 with carry output as 1. Then here again we will add the third one. So here it is 1, 1. So here we have the outputs as 1, 1. As we have prepared the truth table, now we will find out the equations for the output variables as C out and S0. Now here we have 3 input variables. That's why we will go with the 3 variable schema as A, B, C in. Cell numbers as 0, 0, 0, 1 as 1, 0, 1, 1 as 3, 0, 1, 0 as 2, 1, 0, 0 as 4, 1, 0, 1 as 5, 1, 1, 1 as 7 and 1, 1, 0 as 6. Now observe for the C out. here this is K map for C out. So here we will observe this column. Here it is 1 for 0 1 1, that is 3. So we will write there 1. Here for 1 0 1 it is 1, so we will write 1 there. Here 1 1 0 it is 1, so we will write 1 there. And for 1 1 1 it is 1, so we will write 1 there. Because in the sum of product form we have to write 1 for those cell as per the truth table. Now we will form the pair. So here 3 pairs we get form, that of the cell numbers as 3 7 5 7 and that of the 7 6. So that the equation be written as C out equals to, for this 5 7 we have common as A and here common as a C in. So we have A dot C in. The second, for the second pair we have the second term, that is for 3 and 7 cell we have the term as B dot C in. And again the third term for the 7 6 cell number be written as here common as A and here common as a B. So A dot B. Same way we will go for the K map for S0. Again we will prepare the 3 variable K map, as we have 3 inputs A, B, C in. In the K map, gray code is used because of its special feature, that of single bit difference in its preceding as well as in its succeeding code. Here 100 as 4, 101 as 5, 111 7 and 110 as a 6 number set. Now observe here this column for the sum output. Here it is 1 for cell number 1. Here it is 1 for cell number 2. Here it is 1 for cell number 4. And here it is 1 for 111, that is 7. Then we will check for the pair. As pair is not possible here, we will go with the single 1, so that S0 be written as, for this one it will be A complement and here B complement dot C in. Then here for the second, here it is A complement and here it is dot B dot C in complement. Then for this 4, it will be given as A dot with B dot with C in complement. Then for the 7, here A dot with B dot with C in. Then this will be minimized. taking as a common term. So here we will take the common as C in. Or here in these two terms we will take it as, say, A complement as common, remaining as B complement dot C in, or and with B dot C in complement. Then secondly we will take common as A again, and here it is B complement dot C in complement, or with B dot C in. So that this will be written as A complement, and this is B XOR with C in, or with A, and this is B XOR with C in. This XOR with C in again be written as B XOR with C in, or with A B XOR with C in its complement. So now we have the term as A complement B plus A B complement. So this will be written as A complement XOR with B XOR with C input. So here we have find out the Boolean expressions for the C out as well as for the S0, that is sum output. Now using these equations we will draw the logic diagram for the full adder. Logic diagram be given as A, B, C, XOR expression between them be given as the sum output as S0, and A, B, B, C in, and AC in. Or operation between these three and outputs be given with the output variable as C out, that is carry output. This is for the full adder. Again this full adder be expressed with the two half adders as here we have AB XOR operation, that is 1S0 A dot B for the C out of one half adder. Then third input we get added, and this XOR operation be given with here the S0 and these two. With this. And this is the output.